Does money buy wins? This is one of the age-old questions in sports. Now let's explore this in the context of Moneyball. First, by computing what's called the wins efficiency ratio. In other words, how inexpensively can you generate a win based on the payroll for your roster on your baseball team. So we'll look at the relationship between the team payroll in Major League Baseball and the number of wins across the 162 game season, and look at some trends that may change this dynamic in the future in baseball, and also discuss how this philosophy is creeping into other sports like professional football. Now, the Moneyball hypothesis, as documented in the book by Michael Lewis, basically says that in order to get a benefit, some competitive advantage from applying statistics, you need to have both a financial and competitive strategy to employ. And this is essentially what Billy Beane was accomplishing as the general manager of the Oakland A's in the early 2000s. What he found is that there was an undervalue or underpricing or underappreciation of the ability to get on base and avoid making an out. What other clubs were valuing mostly were at batting average or home runs. And what Billy Beane argued is that there were some other things that were even more valuable and underappreciated. So there was a market inefficiency that he was exploiting. And the metrics that were focused on in the Moneyball philosophy were on-base percentage and slugging percentage. Now, you can probably imagine the definition of these, and we'll look at the equations in a little bit. But the idea behind on-base percentage is how frequently does a player get on base. And there are many ways to get to first base, and we will look at the long list of possibilities. Whereas slugging percentage is not just how often does a hitter hit the ball and put it in play safely, but also how many times do they get doubles, triples, or even home runs. And this is an important factor. But it turns out on-base percentage turns out to be even more critical compared to slugging percentage. Now, to get a complete picture of this story, we have to start with the payrolls themselves. So looking back to one of the Moneyball years, which is 2002, the disparity in terms of payroll was humongous. The Oakland A's were hovering around $40 million, and the New York Yankees were in excess of 120, almost $130 million for their roster. Now, digging a little bit deeper into the Oakland A's performance in 2002, there's a couple of things to note, and this is the excerpt from baseballreference.com. The first one is that they actually finished the season with 103 wins, which was actually the same exact number of wins that the New York Yankees finished that year. So the Oakland A's won the first place in their division in the American League West, whereas the Yankees also won first place in their division, the American League East. Another thing to note is that the Pythagorean expectation for wins and losses based on the number of runs scored and runs allowed for that year was only 96 wins. When you compare it to their actual performance, you'll see that the Oakland A's outplayed their Pythagorean estimate by 7 games. So let's look at the payroll as a function of wins for both of these teams. Now you have $40 million for the A's and $125 million for the Yankees. Now I want to show you where I got this data in the layman database and how I created a pivot table to get this very quickly. So let me go to my um, salaries database within the layman structure. So here's all the data. You'll notice that the earliest period when they start collecting salaries is 1985. So this particular data set doesn't go as far back as the batting or the pitching stats in the database. So I'm going to select all this data and insert a pivot table. Now again, what I'm interested in is the year 2002. So I'm going to deselect this and only select 2002. So that's going to be a filter for me. So I'm going to drag that down to the filter space. Now the teams that I'm interested in are only the A's and the Yankees. Okay, so those are going to be, instead of filters, those are going to be rows, because I want the table to be displayed for each of the teams. I want to see what the salary was. And so I'm going to drag salary down to the values region. And what it first tells me is that there were 29 players 29 unique players that were paid by the Yankees that year, and 27 by the A's. And the reason these numbers are different is because obviously there were some trades that took place through the season. But instead of the counts, what I'm interested in looking at is the sum of the salaries for those two teams. And it's a little hard to read without commas, so I'm going to turn that into a $sign, make that row a little bit bigger, and then get rid of the zeros to the right of the decimal point. So there are my two figures, $125 million for the Yankees and $40 million for the A's. And you'll notice that matches the numerator in these two fractions. Now, as a reminder, if you wanted to drill down a little bit and find out how this, who the players were in this payroll and how that added up to 125 million, you can just double click on the team and it brings up the other fields. If we're interested in players, for instance, there are the players for the Yankees that made up that roster. If I was to right click on this column and say sort from largest to smallest, we'll notice that Derek Jeter was the top earner for that particular team, and he was making $14 million that year. Okay, now the other part of that ratio is the number of wins. So let me show you really quickly where to find that. That is a different spreadsheet in the layman database called teams. And again, these are all the teams as far back as 1871, and you'll notice that column I has all the wins. Okay, so I'm going to create a very quick pivot table for this one as well. And again, I'm only interested in the year 2002. And that's going to be a filter for me. I'm only interested in two teams, which are the Yankees and the Oakland A's. And so those are going to be my rows. And finally, I'm going to drag W, which are the wins, down to value. And I'm going to right click on the value. I'm going to say show me the sum of that. You'll notice that in both cases there are 103 wins for both of those teams. So that actually makes the comparison much simpler when the denominator is 103 in both cases. So if you divide the payroll by the number of wins, the Oakland A's, it costs them $388,000 per win. The Yankees, you'll see, cost almost 4 times more money per win because they were carrying such a heavy payroll. And I found a comparison of, again, these two teams, the A's versus the Yankees, a year later in 2003. You'll notice that they won almost the same number of games, yet there was still that very huge disparity in their salary. Fast forward 10 years, and the A's actually outperformed the Yankees by a significant number of games, and there was still this huge disparity in the salary. Now let's talk a little more about on-base percentage. On-base percentage is a ratio where the numerator is the sum of hits plus walks plus hit by pitch, and the denominator is the number of at-bats plus walks plus hits by pitch plus sacrifice flies. Basically, it tries to get at an idea of how frequently somebody gets on base. And you'll notice that the biggest difference here is the numerator, the number of at-bats. Okay, now the list that you'll see here on the left lists 23 different ways to get on base. Now you'll notice that the on-base percentage equation only refers to a few of these: a walk, a single. Okay, there are many more ways beyond that, but it only looks at walks, singles, and hit by pitch, which is reason number 3. Okay, now you could then argue, well, this is not a complete equation. It doesn't cover all these different ways. Well, that's true, but the reality is these are the most common ways in which people get on base. Some of these are very uncommon, very archaic. For instance, fan obstruction doesn't happen very often. Spectator interference doesn't happen very often. Catcher interference, again, doesn't happen very often. So they're only looking at the most common reasons to get on base. So this is an interesting metric because it motivates, it rewards a completely different approach at the plate. Now, if you dig a little deeper, it turns out for that same season, 2002, when you sort the teams on base percentage, okay, in order, you'll notice who first place is in terms of the highest on base percentage, the New York Yankees. You have to go all the way down to 7th place to find Oakland. So in a sense, I think what Moneyball says is, yes, there's a priority on base percentage, but the real key is how expensive your payroll is and how many wins you are generating with that payroll. So you would have expected for Oakland to be number 1 in on-base percentage, but it actually turns out they were not in the year 2002, and they weren't in the year 2003 either. You would have also expected Oakland to be ranked very highly in terms of slugging percentage, but they were not. They were 7th, 8th place in the major leagues in that year. Now, looking at the other metrics, slugging percentage. Slugging percentage is just the ratio of total bases, TB, and at-bats. Now, the term total bases is actually expanded into this weighted sum, and it's weighted because it gives you 4 times as much credit if you hit a home run, 3 times as much credit if you hit a triple, and twice as much credit if you hit a double, relative to just getting a single. So if you were just to only count hits divided by at-bats, this would be batting average. But since you have this weighted sum of giving the batter more credit for getting more bases, then you will always see slugging percentage be higher than batting average, because batters typically hit other things beyond just singles. Now, some of the advanced analytics that are available nowadays, thanks to technologies like StatCast, which is a series of radars and cameras around Major League Baseball fields, is that we can now measure the exit velocity, which is on the y-axis. And the exit velocity is the velocity in which the ball comes off the bat as soon as it is hit. And what's interesting here is that when you compare the slugging percentage for various players to the exit velocity, there's a general upward trend, positive relationship that basically says the harder that a ball is hit, and by the way, these units are in miles an hour, so the harder that a ball is hit, the more bases that you will get as an outcome. In other words, you're going to get a double, a triple, or even a home run more likely if you hit the ball harder. And you'll see that some of these players in the top right are players that you typically see in the All-Star game or in championship teams. Whereas the players you see down here aren't necessarily considered to be sluggers because they don't hit the ball as hard relative to their peers. Again, if you're hitting the ball in the 90s, 90 mile an hour or harder, that gives the fielders less time to react, and it also allows the ball to travel a lot faster and a lot farther towards the outfield. Now, reevaluating this issue of whether money buys success, there's a very interesting analysis on 538.com, that website, that looks at various baseball teams in both leagues, American League and National League. I'm only showing you half the data here. And it's basically looking at how win percentage on the y-axis relates to the salary that a team is contributing. So you'll see a gray line that's has a slight positive trend. You'll see that same gray line in all of the plots because that is the league average. Okay, but for each team, for instance, New York Yankees, which is one of the teams we're talking about, and the Oakland A's, you'll see their own data. So each dot is a season. You'll see that they have their own trend. In the case of the Oakland A's, slightly more money generates a slightly higher winning percentage. Whereas for the Yankees, if they spend more money, their winning percentage goes up significantly up to a certain point where it flattens out and even goes down a little bit. And as you evaluate each team, they all have their own trend, which makes it very interesting. And it makes it hard to generalize this question about whether more money buys more wins. Because in some cases, like the Toronto Blue Jays, you'll see that as they spend more money, their winning percentage actually goes down slightly. Whereas the Texas Rangers are also in that pattern, where as they spend more money, their winning percentage goes down. On the other hand, there are some teams that have a huge benefit from spending more money. I would say the Seattle Mariners, you see that upward trend, it's unmistakable. And you also see the Cleveland Indians. As they spent more money, they've seen a very good return on their investment. So going back to the question of whether you can buy wins or whether money leads to success, well, it depends who you are. If you're the Tampa Bay Devil Rays, I would say the answer is probably no. Small market team, they don't get a return on their investment. But if you're the Los Angeles Angels of Anaheim, there is definitely an upward trend, but there are some diminishing marginal returns. In other words, as you spend more money, you actually don't see the same benefit than you saw when you're spending less money. What's interesting about Moneyball is that one of the characters in that movie was Paul DePodesta, and he was portrayed to be a nerdy little assistant to Billy Bean, and a lot of the sort of magic implementation of the Moneyball magic was done by Paul DePodesta. Now, he moved on from the Oakland A's to work for various other teams, including the New York Mets. But a few years ago, he actually made the transition from baseball to football. So over the last few years, he has been the chief strategy officer for the Cleveland Browns. And what's interesting is that a lot of the decisions that the Browns are making now, as they relate to the draft, have a Moneyball feel to it. So look out, keep your eye out for the Cleveland Browns, and we'll see if the strategy that worked in baseball translates over to American football. Now, one of your objectives is to dissect what Wayne Winston has to say about the relationship between money and success in chapter 46 of the Mathletics book. A few other trends to note, though, in terms of Major League Baseball, and this is going to change the economics and it's going to change the dynamics of player recruitment. One of them has to do with the trend of the salaries over time. So in the plot on the top left, you'll see that it begins in the 1970s and it goes all the way to 2010, where the blue line on the bottom, this is the minimum salary for a player on a Major League Baseball roster. And then the average salary, you'll see, has a significant upward trend. Since 1970, the salaries have been going up significantly. So therefore, that has an effect on the salary cap and the payroll of teams. Another interesting trend is the makeup, the cultural makeup of baseball teams. Again, going back to the 1960s all the way to the early 2000s, sort of the Moneyball era, you'll see that the percentage of players from the Caribbean, that is Cuba, Puerto Rico, Dominican Republic, Venezuela, is grown significantly. And this is interesting in a lot of ways because the way that these players are drafted and the way that they are nurtured through the minor league system is a very different strategy than you would a player, say, born in the U.S. and going through the minor league system as a native player, but also maybe even through the college baseball system. Another interesting trend, and this one goes more than 100 years, so it's not the same scale as the two graphs above, but this is the height of a baseball player. It's amazing how tall some of these pitchers are. Some of them are almost 7 feet tall, 6'9", 6'10". So it's really driven the height, the average height, significantly in the last 140 years. And finally, the last graph that I thought was interesting, the last trend, this one goes from 1950 to 2012, and it's looking at the attendance per game, and it's really trended upwards in terms of how many people attend baseball games. Right now, it's in sort of the region of 30,000 players per game. I'm sorry, fans per game. And this is not only tracked as a percentage of stadium capacity, but also as a percentage of the metro population in that particular region. So certainly an upward trend in popularity, an upward trend in attendance relative to the capacity of the stadium. These things are the types of phenomena that drive the economics of baseball and other professional sports.